Good morning. Quality, where you are? Quality. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, December 24, 2021, Friday. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक 24 दिसंबर 2021 शुक्रवार का दिन और पहला वीडियो टूट गया 33 मिनट पर, लास्ट वीडियो ऑफ 33 मिनट्स because it broke, and now I try again, and this is second video today, talk being civil field engineering, life, engineers concrete specifications, quality, AnnexSL, and contracts, and of course everything as seen before. You can read this title yourself, no issue. I was talking about quality file that I have. I was here on this that just degrees are not adequate even if one is a doctorate, and it's because experience and that to quality based on. I just took out, I can browse this file again, this page again. This is what I talked on quality. This is a new proposal today. Quality in Bharat, India, where does quality exist? That is the question here. Quality hai kahan? And we discussed about this some. Just degrees are not, you can say, adequate, even if it's doctorate, until engineers attainment or engineers educational standards and practical aspects tally together. If your work does not does not prove that it is quality one, in that case we can say we have to conclude that our education is not to that mark it should be. Some defect lies in education, and that defect is known that we are not oriented on practicalities of engineering, but just theoretical approach is adopted, and we think this is milestone we have achieved. If someone has got BE or first degree in engineering, or then second engineering degree, and that is master's, or otherwise top engineering degree, that is doctorate. As far as degrees are concerned, it's nice, one should have as many as possible, but degree of experience is, I think, something different. Those who have experience of quality, they are nice people. That is where you can say your educational degree is justified. If you cannot achieve engineering standards, if you cannot achieve product efficiency, product performance, how can you justify that you are a good engineer? Engineer means both quantity and quality in quantity. It's not separate. No quality can be separated from quantity, because quality has no existence. It is a part of product. I cannot say, you see, quantity of this product is this and quality is that. That is impossible, because quality is an integrated part of quality, is an integrated part of quantity, and quality is an inbuilt system in quantity. Every product unit must have that educational qualification. Educational means inbuilt quality, inbuilt parameters of quality, and that education can be given only by engineers. Here, engineer is a manufacturer of quality. If engineer is unable, when I say engineer, it means all those workers involved in production of whatever. And based on experience, It's based on experience, or you can say work attainment. Work attainment, how good one is to produce something that is more and more reliable. And that reliability factor goes on enhancing or increasing day by day due to good practice maintained and conducted. Experience and that to quality one based must be a must, I should say. If you say no, it should be, I don't expect and I don't accept. As far as quality is related to, it's very sad situation in many countries, but I'm talking of my country, India, Bharat, that quality currently is in very bad state, worst state I can say. I don't understand why people do not talk of quality. For them, everything is quality, good or bad. They will just say, oh, quality doesn't know, we do not know quality, what is quality, everything is quality. Yes, take it and go ahead. You buy what your material, you are fortunate enough if you have good quality material by chance. Otherwise, in 98% cases, you would be upset. You would be upset, but nobody would realize problem behind that. And that's another point of concern. Why don't we think about that always? We do not think about that, and which is the reason that we can't get quality. And why don't we get quality? There's one more reason behind that. That is prime reason. Whatever we have to do, we just do it without thinking best in that way, without analysis, without doing any analysis, and without getting complete information. We just want to do that. When I talk of all products, it's not of alone the civil engineering product, it is all product. To achieve quality is very important. Many of you might be thinking, I always waste time while talking quality. You can think. Some people say about safety, health and environment. Same way everybody says sometimes, oh, we are safe, there's no problem, we take care of everybody, you are only wasting time. Yes, I am wasting time because I am concerned. You are not wasting time because you are not concerned. Safety, health and environment are prime necessity of life, and quality is product necessity of life, while quality is not related to product alone. Quality is related to individual also, because everybody is trained, academically or otherwise, everyone is trained, and that training must speak of our standards, our achievement. Quality is not a miracle. It's a requirement. It's physique. We should do it. If we do not, I don't know reason, why don't we care about this? I don't know reason. Who knows reason? Everybody knows reason, that we are careless. We are careless. We don't concentrate. We don't want to follow some defined procedure, and in fact, we don't define procedure. Because we know every procedure. You know, we used to say sometimes, I know everything. I know it. Okay, you know it fine. But you don't know do it. Why don't do it? Oh, no, I did it. Might be something missed. Yes, that's what I say. You did it, something was missed. Why was it missed? Why was it missed? That is my cross question. And that's my duty to raise cross question, just like cross examination. Why did you miss it? Because you did not have intention to follow it. You did not have any intention to concentrate on this. Concentration, follow-up, keeping in mind are very ordinary properties, ordinary acts. Because you have to think. If you have to think, you will concentrate. You will keep in mind every requirement. आप अगर सोचते हैं मुझे गुणवत्ता पानी है, मुझे क्वालिटी पानी है, तो आपको सोचना तो पड़ेगा। और ये कोई ऐसी चीज़ नहीं है जो आप वो पाना चाहते हैं जो पहले किसी ने पाई नहीं होगी या विश्व में कहीं और नहीं पाई जाती होगी। गुणवत्ता सारी दुनिया में चलती है। जहाँ लोग जागरूक हैं, जहाँ लोग होश में हैं, वहाँ चलती है। और जहाँ बेहोश हैं, जहाँ सोना चाहते हैं, जहाँ ध्यान नहीं देना चाहते हैं, इसमें हम एक उच्च वर्ग के देश हैं। उस कार्य में शायद मैं कह सकता हूँ, अगर आप गुणवत्ता का आकलन करेंगे तो हम दुनिया में गंदी गुणवत्ता में सबसे टॉप पे हैं या अच्छी गुणवत्ता में सबसे नीचे होंगे। शायद ऐसा हो सकता है। मैं बुरे विश्वास से नहीं कह सकता, लेकिन ऐसा लगता है। आज के समय जब 2021 चल रहा है, जा रहा है, 2022 प्रवेश करने वाला है, हमारी गुणवत्ता का हाल मरा हुआ है। In fact, I can say we are dead bodies in quality. Our quality is dead. Our quality is dead, not only in production or in material, but also in individuals. You can check individuals, particularly those millennials and young and budding. You shall know facts yourself. Yes, they are excellently, appropriately, you can say, qualified for operating software, but not workwear, not physical workwear they are. They can use software, of course, that is very good character, very good parameter for performance, but not complete parameter. हम उनकी तुलना किससे करें, हम नहीं जानते। हमारा युवा बहुत इंटेलिजेंट है, हम ये भी जानते हैं, लेकिन इंटेलिजेंट होना काफ़ी नहीं है, काम करना भी आवश्यक है। अगर आप इंटेलिजेंट हैं, काम नहीं करते हैं, तो आपका इंटेलिजेंट होना या ना होना कोई फ़र्क नहीं पड़ता। और आप कमिटेड हैं और इंटेलिजेंट हैं तो फ़र्क पड़ता है। अगर आपने सोच लिया ये काम करना है तो करना है, और अगर आपने सोचा नहीं करना है तो नहीं करना है। क्या करेगा कोई, नहीं करते हम। Question arises, and that's why I always say in this title, Civil Field Engineering. Field engineering is perfect world where every subject is involved, and I say life is involved, and engineers are involved. And of course I say concrete specs, because concrete is a prime product that is used in developing world. And when concrete comes into picture, of course concrete carries many other items with it. It carries individuals, it carries temporary material, it carries proprietary material, it is permanent material, and it's based on contracts and designs. Because without designs we can't concrete, and without contracts what can be done. So we can say design and construction are important from that viewpoint. And of course how we operate contract, that is through methods, and methods means contracts, and without methods nothing can be done. Methods are very important in profession of engineering, Technically speaking, without methods, no profession can move. And when engineering comes into picture, into consideration, it is full of methods. All are methods, all subjects are based on methods. Methods or procedures, you can say, or you can call by whatever name. This cannot move. And then we have to see when relations exist between owner and contractor, those relations can lead to disputes also. Though disputes are not 100%, few percentage only of amount of work, but yet disputes are disputes, and these have to be resolved at certain level where amity does not exist. Professional differences do exist. Misinterpretation, or you can say contract loopholes, or some people want to get more and more due to so many parameters, so many reasons. Disputes of course appear, otherwise there should be no reason why should dispute occur. It's only due to many reasons. It can be absence of some provision in contract, or absence of good specifications in contract. There may be something which is not indicated or given as mandate, but it is done. You can say issue of communication and coordination, because at time of bidding, communication was not perfect or coordination remained imperfect. All these carry some problems. And that's why I say think about quality. It's not my statement, be very clear, it's not my statement. I'm just using this statement. It is engineering statement. It is statement of requirement that we have to think quality. Why we think only quantity? Why don't we think of quantity plus quality? We spoil our quality if we don't care for quality. I'm sure quality won't care for us, good work won't care for us, and you can say we won't be able to do business at one point of time. When we reach, people shall trust our product. It happens these days. If you buy whatever item, it won't support you forever or even for warranted time due to possible defects during performance that we may observe. That's the reason I say my inclination of this talk was just to again raise fever of quality. Somebody may call it quality phobia. Yes, it is quality phobia, you can say, because it's material, it's human, it's technology, they're all combined together for permanent work. And this permanent work is not some car or some tool or some spare part that we have to change again and again, again and again. We can change these parts, these machines, that after 2 or 3 or 4 years or 5 years, these have no value. These have no value. New designs come in. But as far as civil engineering world is concerned, permanent works are not only for years, it is for life. Yes, I am talking of roads and not very much interested because you have to repair it every year. But for structures, I'm talking structures which are meant for many, many decades to come, where our savings, you can say, life savings, go on to be invested in. Otherwise, we can't get development work done. That's behind this consideration here, and you can say try to explain because of seriousness in this case. And we have here our file of concrete. We can say it's talking about concrete. Last time we talked about liquid membrane, And we can say steam curing, we talked of about 65 to 80 degrees Celsius, and fluctuation in temperature not to exceed 22 degrees Celsius per hour, and maximum steam temperature to be maintained in enclosure until concrete has reached. And we talked of bridges, we talked of pavements and other slabs on ground, and then building bridges and other structures. Additional curing shall be provided after removal of forms. So we discussed about that also, about 11 degrees difference of temperature. We said the very important point was 11 degrees, that curing water should not be more than about 11 degrees Celsius cooler than concrete. It's an important point. If concrete is 35 degrees Celsius, for example, 35 minus 11 is 24. So water should be 24. If concrete is 30, same way it should be 19. Likewise, this is just the range. Just the range and not more than that. Mass concrete we discussed. And we discussed about how these, you can say, these specific materials work. And we talked of, you can say, welded steel wire fabric and also tie wire. Now we talked of special, this is cutting and bending of reinforcement. We talked of fixed reinforcement, and then we can say there is mechanical splices, bunding and supplying of bundle bars. Here is, let us say here somewhere we have to start. So we can say welding, I think we are done. Let me read it better. We will know what we did, what we don't did. For welding, welding should not be used unless, you can say, welding shall not be used unless authorized by engineer and recommended by reinforcement manufacturer. So this was done. Where welding is approved, it shall be executed under controlled conditions in a factory or workshop. So it says that where welding is approved, it shall be executed under controlled conditions in a factory or in a workshop. Welding shall not be done on site without approval of engineer or approval given by engineer, and unless suitable well safeguards and techniques are employed and types of steel employed have required welding properties. So welding shall not be effected on site without approval, and unless suitable safeguards and techniques are employed, types of steel employed have required welding properties. Welding, if approved, may be used for fixing crossings or lapping reinforced in position, fixing bars to other steel members, structural welds involving transfer of loads between reinforcement or between bars and other steel members. Deposited in a single pass shall not exceed 5 times bar diameter, that is length of run, deposited in single pass shall not exceed 5 times bar diameter, 5D. If a length of run deposited in a single pass shall not exceed 5 bar diameter, If a longer weld length is required, welds shall be divided into sections with the space between runs made not less than 5 times bar diameter. Butt welds shall be formed by flash butt welding or metal arc welding. Other methods may be approved subject to their satisfactory performance in trial joints. We had discussed about metal arc welding or electrical resistance welding may be used for fixing suitable steels or for lap joints. Flash butt welding shall be executed with correct combination of flashing, heating, upsetting and annealing, using only machines which automatically controls this cycle of operations. Metal arc welding shall comply with European Union EN 1011 and recommendations of reinforcement manufacturers. Welded joints shall not be bent. Welded shall not be made at bends in reinforcement. Welded joint shall not be made at bends in reinforcement. Joints in parallel bars of principal reinforcement shall be staggered. Shall be staggered. Shall be staggered. Joints shall be not less than n anchorage length joints. Weldable reinforcement where shown on drawing shall conform to ASTM 706. Mechanical splices shall comply with BS 8666 and shall be used as and where indicated on drawings. Details of mechanical splices shall be submitted to engineer for approval. And bundling and splicing bundle bars. Bundling and splicing of bundle bars shall be in accordance with BS 8666 or given even. Splicing, except where indicated on drawings or approved, shall not be permitted without approval of engineer. Contractor shall notify engineer at least 24 hours before commencing fixing of reinforcement in order to facilitate inspection of formwork. Contractor shall ensure that access area to receive reinforcement are cleaned before fixing. Be fixed are placed in contact with known ferrous metals. Cover correct concrete cover to reinforcement shall be maintained with aid of approved spacer pieces. Cover shall not be less than given in section 5.6. We'll see spacers, chairs and other supports shall be provided as necessary to maintain reinforcement in its correct position. In a member where nominal cover is dimensioned to links, spacers between links and formwork shall be same dimension as nominal cover. Spacers bar shall be of same diameter as longitudinal bars, but not less than 25 mm in diameter, and shall be fixed between two layers of 1.5 meter centers, except where bundle bars. Spacers, chairs and other supports shall be made of concrete, plastic or other materials. Spaces, chairs, and other supports shall be made of concrete, plastic, or other materials to approval of engineer. Where supports are made of concrete, they shall have at least same cube strength as concrete has. Reinforcement. Placing of all reinforcement steel bars to be checked by engineer, or and in no case is concrete to be placed around whatever or any reinforcement steel that has not been approved by engineer. Insertion of bars into or removal of bars from concrete already placed is not permitted. I think we had gone through like this, but I'm just reading reinforcement. Reinforcement steel temporarily left projecting from concrete at joints shall not be bent without prior approval. Damage to forms and linings shall be avoided. Reinforcement shall not be fixed until completion of placing tanking membrane protection. Adjustment and cleaning, checking position of reinforcement before and during placing concrete. Adjustment and cleaning is a very important point. Of reinforcement before and during concrete placing. Pay particular attention to position of top reinforcement in cantilever sections. We have done this. Sorry, some problem in my throat. Ensure that reinforcement is clean. Ensure that reinforcement is clean and free from corrosive pitting, loose rust, mill scale, oil and other substances which may adversely affect reinforcement. Concrete or bond between two. Protect projecting reinforcement from weather where rust staining of exposed concrete surfaces may occur. Protect projecting reinforcement from weather where rust staining or exposed concrete surfaces may occur. At time of concreting, all reinforcement steel shall have been thoroughly cleaned and freed. At time of concrete, all reinforcement steel shall have been thoroughly cleaned and freed from all muds, oil, or any other coating that might destroy or reduce bond. Clean all set or partially set concrete which may have been deposited thereon during placing of previous lift of concrete. All uncoated rust bars shall be again sandblasted and pressure washed. Immediately concrete placing. Immediately before concrete placing, reinforcing steel shall be washed. Reinforcing steel shall be washed thoroughly with high pressure potable water jets to remove any deposited salts. Protective coating to reinforcement. All foregoing clauses of this part apply equally to epoxy coated reinforcing bars. Epoxy coated reinforcing bars. Reinforcing steel which are to be coated shall be free of slivers, scabs, excessive pitting, rust, grease, oil, and other surface defects detrimental to proper coating. Surfaces shall be prepared in accordance with ISO 14654. Coating shall be applied to cleaned surfaces. Coating shall be applied to cleaned surfaces as soon as possible after clearing and before any visible oxidation to surface occurs. Reinforcing steel shall not have surface defects that would be detrimental to coating. Epoxy resin powders which do not meet these requirements must be tested by an approved independent testing laboratory and must be accepted by engineer before use. Only fusion bonded epoxy coated reinforcing steel shall be accepted. Only fusion bonded epoxy coated reinforcing steel shall be accepted. No other means of epoxy coating shall be approved. Patching material shall be furnished by epoxy coating manufacturer compatible with coating, inert in concrete, suitable for repairs to coated reinforcing bars to be made by coating applicator and contractor at project site. Fabrication shall be performed before coating except as hereafter specified for bent bars and straight bars less than 7.6 meter long. Bent reinforced steel bars shall be coated after bending unless fabricator can show that satisfactory results can be coating on outside of bend or damage to coating resulting in debonding of coating after bending shall be rejected. Bars less than 7.6 meter long may be sheared or sawn to length after coating provided and damage to coating does not extend more than 12 mm back. Cut end is patched before any visible oxidation appears. Flame cutting shall not be permitted. Epoxy coating shall be checked visually after cure for continuity of coating and shall be free from holes, contaminations, cracks and damaged areas. There shall not be more than 2 holidays, pinholes not visually discernible in any 300 mm of epoxy coated bar. A holiday detector shall be used. A holiday detector shall be used in accordance with manufacturer's instruction to check epoxy coating for holidays. A 67.5 volt, a 67.45 volt detector such as Tinker and Racer model M1 or is approved equivalent of holiday. Patching of holidays is not required if there are less than 3 holidays per 300 mm length. Bars having 3 or more holidays. Bars having 3 or more holidays per 300 mm shall be cleaned and recoated or replaced as directed by engineer. Epoxy coating film shall be cured and or post cured to a full curved cured condition. Representative proportion of each production lot shall be checked by epoxy coating applicator using method most effective for measuring cure to ensure that entire production lot of epoxy coating is supplied in full cured condition. Contractor shall repair all coating damaged by fixtures used to handle or support bars in coating process as follows. Patching shall be done as soon as possible and before visible oxidation occurs. Excessive patching correction satisfactory correction shall consist of proper adjustment of process. Satisfactory correction shall consist of proper adjustment of process and rerunning bars through plant. Satisfactory correction shall consist of proper adjustment of process and rerunning bars through plant. Engineer reserves right for access to epoxy coating applicators plant to witness epoxy coating processes for project work and to obtain specimens from test bars for whatever testing desired. All chairs, tie wires and other devices which used in connecting, supporting, securing or fastening epoxy coated reinforcing steel bars shall be made of or coated with dielectric material. All chairs, tie wires and other devices used in connecting, supporting, securing or fastening epoxy coated reinforcing steel bars shall be made or coated with a dielectric material. Before reinforcement is lowered into place and before placement of concrete, coated bars shall be inspected by engineer for damage to epoxy coating. Sheared ends of bars and other areas requiring limited repair due to scars and minor defects shall be repaired using specified patching or repairing methods. Handling of epoxy coated reinforcement. Coated reinforcement. Reinforcement steel bars shall be handled and stored in a manner to prevent damage to bars or where used epoxy coating. Signals are down again. Reinforcement steel bars shall be handled and stored in a manner to prevent damage to bars or where used epoxy coating. Bars or where used epoxy coating damaged in handling or other operations shall be satisfactorily repaired at no additional cost to employer. Where epoxy coated bars are used, all handling systems shall have plastic mandrel and padded contact around contract areas where possible. Where epoxy coated bars are used, all bundling bars bands shall be padded. All bundles shall be lifted with strong back, multiple support or a platform bridge so as to prevent bar to bar abrasion from sags in bar bundle. Bars, you can say, bars or bundles shall not be dropped or dragged. During vibration, care shall be taken to ensure that epoxy coated reinforcement is not damaged by pokers. Testing of epoxy coated reinforcement. Adhesion, adhesion and flexibility. Adhesion and flexibility of epoxy coating shall be evaluated on test bars coated with each product lot. At least 1% length of 1% length or 6 meters, whichever is less, of each size of bar to be coated shall be furnished as test bars. Test bars may be in one length or multiple lengths as required to have one test bar of each size with each production lot. Production epoxy coated test bars shall be evaluated by bending 120 degrees after rebound around a mandrel of diameter corresponding to size of bar that is given in table. Of course, we have gone through again. I'm saying with 10 mm 79, 12 mm 95, that's what the bar diameter is, and diameter of mandrel is for 10 mm 79, for 12, 25, 13 like this, or 14, 111, and 16, 137, 18, 143, 20 is 19. So you can say 20 is 159, 8 times. Approximately, I think it's 8 times approximately. If you take 34, yes, I think it's 8 times average, less than 8 times, we can say here approximately. But I understand the relation between mandrel diameter and bar diameter. Approximately 8 times it is. It is 10 at 79, 10 is 80, so it's 79. In place of 96 is 95. Likewise, it's 8 times. That is generally we can say here. That is, bend shall be made at uniform rate and may take up to 1 minute to complete. Bend shall be made at a uniform rate and may take up to 1 minute to complete. Bend test shall be conducted at a room temperature of, that is, between 20 degrees Celsius and 30 degrees Celsius after the specimen has been exposed to room temperature for a sufficient time to ensure that it has reached thermal equilibrium. No cracking of epoxy coating shall be visible. No cracking of epoxy coating shall be visible to eyes on outside result radii of bent bar. Now we are going to joints. We were talking about joints last time. when we are talking of construction joint. What is construction joint? It's an important point to care about that. Construction joint. Where construction joints are required. Where construction joints are required, let me just a minute. Where construction joints are required, in slabs or beams. Very cold it is, what to do? Where construction joints are required in slabs or beams designed by direct design methods, that is DDM, they shall be located within middle third or their spans and at 1/3 to 1/4 of span in slabs and beams subject to maximum spacing of approximately 9 meters. Where slabs are supported by beams, then beams and slabs shall be constructed in one operation. In all cases, vertical stop boards of a form to be approved by engineers shall be provided at end of each section of work, which is to be concreted in one operation, and concrete shall be thoroughly compacted against the stop boards. Where slabs, beams, and walls incorporate construction joints, panels shall generally be constructed consecutively. Where this is not possible, a gap not exceeding 1 meter shall be formed between adjacent panels. This gap shall not be concreted until a minimum interval of 7 days has expired since casting of most recent panel. It says where slabs, beams and walls incorporate construction joint, that's when slab, beam and wall incorporate construction joint, panels shall generally be constructed consecutively. Where this is not possible, a gap not exceeding 1 meter shall be formed between adjacent panels. This gap shall not be concreted until a minimum interval of 7 days has expired or elapsed since casting of most recent panel. Size of base for reinforced plates, size of base for reinforced floors, walls and roofs shall be shown on drawings, but in no event shall they exceed 7.5 5 meter. Size of base for reinforced floors, walls and roofs shall be as shown on drawings, but in no event shall they exceed 7.5 meter in either direction and 6 meter when unreinforced or with nominal reinforcement. Horizontal construction joints in walls will only be permitted when wall is continuous with floor slab. Walls shall be keyed on cast kickers. Walls shall be keyed on cast kickers 150 mm high or on tops of walls meeting soffits of suspended members. Walls shall be keyed on cast kickers 150 mm high or on top of walls meeting soffits of suspended members. Construction joints in monolithic structures shall be aligned with each other whenever practicable. Before placing new concrete against concrete which has already set, later shall be treated to expose aggregate over full section and leave a sound, irregular surface. This shall be done while concrete is still fresh by means of water spray and light brushing or other means approved by engineer. What it says, construction joints in monolithic structure shall be aligned with each other wherever practicable. Before placing the concrete against concrete which has already set, later shall be treated to expose aggregate over full section and leave a sound regular surface. It shall be done while concrete is still green or still fresh by means of water spray and light brushing or other means approved by engineer. Immediately before new concrete is placed, all foreign material, all foreign matter shall be cleaned away and surface. If during course of contact it should become apparent that contractor's method of forming construction joints are not proving effective, engineer may order contractor to execute at contractor expense such preventive measures as engineer may consider necessary to ensure water tightness of construction joints in further work. Construction joints in water retaining structures. Construction joints in water retaining structures. Floor may be designed fully restrained against shrinkage. Floor may be designed as fully restrained against shrinkage and thermal contraction and should be cast directly onto blinding concrete. Floors may be designed as fully restrained against shrinkage and thermal contraction and should be cast directly into blinding concrete. In large structures, floor shall be designed as series of continuous steps. In large structures, what it says first, floor may be designed as fully restrained against shrinkage and thermal contraction and should be cast directly onto blinding concrete. In large structures, floor shall be designed as series of continuous strips with transverse induced contraction joints. Floor shall be designed as series of continuous strips with transverse induced contraction joints provided to ensure that cracking occurs in predetermined position. Longitudinal joints between strips should water stops. Water stops shall be incorporated into construction joints. Crack induced joints, contraction joints, and expansion joints in water retaining structures. Water stops shall be incorporated into construction joints, cracked induced joints, contraction joints, and expansion joints in water retaining structures. Contractors shall ensure that all such joints are watertight, and whatever joints which may leak or weep shall be rectified by contractor to engineer satisfaction. Spacing of construction joints, crack induced joints, contraction joints, and expansion joints in water retaining structures shall be shown on design drawing. Where position or type of joints are not indicated on drawings, spacing of construction joints or cracked induced joints in water retaining structures shall not exceed 5 meters. Where position or type of joints are not indicated on drawings, spacing of construction joints or crack induced joints in water retaining structure shall not exceed 5 meters. Where position or type of joints are not indicated on drawings in ground floor, slab, construction joints, cracked induced joints, contraction joints, and expansion joints shall be incorporated into works as appropriate for slabs on grade. Construction joints or crack induced joints, construction joints or cracks in joints should be provided at areas where differences in subgrade and slab support may cause cracks. Says again, it's different. Where you can say where position of type of joints are not indicated on drawings, ground floor, slab, construction joints, cracked induced joints, contraction joints, and expansion joints shall be incorporated into works as appropriate for slabs or grade. Construction joints or crack induced joints should be provided at areas where differences in subgrade and slab support may cause cracks. Slab shall be cast in strips not more than 15 meters wide across width of building. Within each strip for both direction, crack induced joints shall be provided at areas where cracks are expected and not more than 5 meter spacing, and construction or contraction joints shall be provided at not more than 15 meter spacing. Construction or contraction joints shall be provided between adjacent steps. Water stops of type acceptable to engineer. Water stops of type acceptable to engineer shall be embedded in concrete. Water stop should be made of a high quality material which must retain its resilience through service life of structure for double function of movement and sealing. Surface of water stop should be carefully rounded to ensure tightness of joint even under heavy water pressures. Even under heavy water pressures, to ensure a good tightness with or without movement of joints, water stop should be provided with anchor paths. Cross section of water stop should be determined in accordance with presumed maximum water pressure and joint movement. Complete works of fixed and welded connections. Complete works of fixed and welded connections must be carried out strictly in accordance with manufacturer's instructions. Engineer's acceptance shall be obtained by contractor prior to start of work on casting, sequence and layout of joints, movement joints. Movement joints, let me go to C first to explain again these joints. Here is construction joint. It says, just for reminding what we talked of, says construction joint, surface where two successive placements of concrete meet. Surfaces where two successive placements of concrete meet, across which it is desirable to develop and maintain bond between two concrete placements, and through which reinforcement which may be present is not interrupted. Contraction joint, formed, sawed or tooled groove. Formed, sawed or tooled groove in a concrete structure to create a weakness or weakened plane and regulate location of cracking resulting from dimensional surge. So we can say contraction joint, formed, sawed or tooled groove in a concrete structure to create a weakened plane and regulate the location of cracking resulting from dimensional change, a different part of structure. Expansion joint, separation between adjoining parts of a concrete structure. Separation between adjoining parts of concrete structure which is provided to allow small relative movements such as those caused by thermal changes to occur independently. Isolation joint, Isolation joint means separation. Separation between adjoining parts of a concrete structure provided to isolate and eliminate element and thus allow independent movement. So we can say isolation joint is separation between adjoining parts of concrete structures provided to isolate and eliminate and thus allow independent movement. So there's two. One is expansion joint, separation between adjacent parts of a concrete structure, which is provided to allow small relative movement, such as those caused by thermal changes to occur rapidly. Isolation joint between a separation between adjoining parts of a concrete structure provided to isolate an element and thus allowing independent movement. Joint fillers, materials that used to fill space with movement. So we can see joint fillers, materials that are used to fill spaces within movement joints. During construction, they may provide support to sealant applied subsequently. We discussed section joint also, I think, right? Construction joints, water retention is discussed. Now, movement joints. Movement joints for expansion and contraction shall be constructed in accordance with details and to dimensions shown on drawing. Should you? Movement joints for expansion and contraction shall be constructed in accordance with details and to dimensions shown on drawings or where otherwise ordered by engineer and shall be formed of element specified. Movement joints in water retaining structures shall be in accordance with details and dimensions shown on drawing. Contractors shall pay particular attention to effect of climatic extremes on any material which you may desire to use on any movement joint and shall submit for approval by engineer his proposals for proper storage, handling and use of said materials, having due regard for whatever recommendations made by manufacturers in this connection. Contractors shall pay particular attention to effect of climatic extremes on whatever material which you may desire to use on movement joints and submit for approval by engineer, proposal for proper storage, handling and use of said material, having due regard for any recommendations made by manufacturer, joint fillers, joint fillers, joint fillers shall conform, no signals what to do. Joint fillers shall conform to the requirements of BS 6093 or STMD 1751 or equivalent if they are bituminous type, or the requirements of different codes equivalent if they are polymer form type, bituminous type or polymer form type. Both are available. Joint filler shall be fixed to required dimensions of joint cross section. Joint filler shall be fixed to required dimensions of joint cross section and shall provide a firm base for joint sealer. When required between two concrete surfaces, when required between two concrete surfaces as a resilient movement joint, filler shall be an approved granulated cork bound with insoluble synthetic resin. Says when required between two concrete surfaces as a resilient movement joint, filler shall be an approved granulated cork bound with insoluble synthetic resin. Again, it's important when required between two concrete surfaces as a resilient moment joint, filler shall be an approved granulated cork bound with insoluble synthetic resin. When required between blockwork and concrete as a low density moment joint filler or for building details, it shall be an approved bitumen impregnated fiberboard. Is bitumen impregnated fiberboard or preformed closed cell polyethylene. Joint sealant. All joints to be sealed shall be formed and groove grit blasted. All joints to be sealed shall be formed and groove grit blasted to remove all traces of deleterious materials such as foam, oil or curing compounds, and also to remove whatever surface latents from sides of joint. All joints to be sealed shall be formed and grooves grit blasted groove grit blasted to remove all traces of deleterious materials such as foam oil or curing compounds, and also to remove whatever surface latents from sides of joint. Joints shall be dried prior to application of priming, where use of grit blasting is not possible. Shall be dry prior to application of priming, where use of grit blasting is not favorable. So we have said that, what was that? Joints shall be dried prior to application of priming, where use of grit blasting is not possible. Contractor may provide or may propose alternative methods subject to approval engineer. Back of joint shall receive a debonding tape. Back of joint shall receive a debonding tape or polythene foam backer. Polythene foam backer cord in order to provide correct depth to width ratio and prevent three-sided adhesion. Areas adjacent to joint shall be protected using masking tape. Sides of joint shall be primed with relevant primer that is recommended by sealant manufacturers, and sealant material Alright, so we can say that sides of joints shall be primed with relevant primer as recommended by sealant manufacturer, and sealant material applied in accordance with manufacturer's instruction. Sealant material shall be non-biodegradable. Sealant material shall be non-biodegradable. Multi-component pitch, polyurethane elastomeric joint sealant, carefully selected as appropriate for specific climatic and environmental exposures conditions expected. Alternative type of sealant. where joint sealant is to be in contact, joint sealant material shall be non-biodegradable, multi-component pitch, polyurethane, elastomeric joint sealant, carefully selected as appropriate for specific climate and environment exposure conditions expected. Alternative types of sealant shall be considered, including epoxy, polyurethane, rubber bitumen, and acrylic, subject to requirements of specification and approval of engineer. Where joint sealant is to be in a contact with protective coating, contractor shall satisfy engineer that sealant and protective coating are compatible. Where joint sealant is to be in contact with protective coating, when joint sealant is to be in contact with protective coating, contractor shall satisfy engineer that sealant and protective coatings are compatible. Sealants shall exhibit following properties. Sealants will exhibit following properties, which are moment accommodation factor 25%, moment accommodation factor 25%, shore A hardness 20 to 25, solid contents 100%, service temperature range 0 to 90 degrees Celsius, chemical resistance to sewage, subbuca, mineral salts and alkalis, width to depth ratio 2:1, width to depth ratio is 2:1. Where shown on drawings, sealants shall also be suitable for use with potable water. All surface preparation, priming, mixing and application shall be carried out in strict accordance with manufacturer's instructions. Sealant shall have a proven track record of no less than 10 years under similar local conditions. Sealer shall have a proven track record. Sealant shall have a proper track record of no less than 10 years under similar local conditions. Slip bearings, general. Slip bearings shall be preformed. Slip bearing shall be preformed, low friction bearing strips to form a thin sliding joint. Slip bearing shall be preformed. Slip bearing shall be preformed, low friction bearings strips to form a thin sliding joint. This shall be extruded from specially formulated polyethylene to form a durable lamina resistant to sewage, mineral acids and alkalis, solvents and weathering. So we're talking of slip bearing. Slip bearings shall be preformed, low friction bearing strips to form a thin sliding joint. Shall be extruded from specifically formulated polyethylene to form a durable lamina resistant to sewage, mineral acids and alkalis, solvents and weathering. Slip bearings shall be applied in two layers, with bottom layer bonded to substrata with a high quality solvent borne adhesive based on polychloropyrene. Polychloropyrene. Okay. Applied loads, you know, what it says that substrata shall be clean and free from deleterious materials such as foam, oil, or curing compounds, and suitable and surface latents. Surface shall be level and not even along full length of joints. So to say, here surface shall be level and even long full length of joint. Applied loads for slip bearings shall not exceed 0.7 MPa. Applied loads only 0.75 MPa, 0.7 MPa. Operating temperature shall be up to 80 degrees Celsius. Coefficient of friction shall not exceed 0.15. Water stops. General. Water stops. General. Water stops and associated materials shall be by a manufacturer with a minimum 10 years experience in field of engineering water products. PVC water stops shall be suitable for storage, handling, installation and service with a range of 15 degrees to 65 degrees Celsius. I then say water stops and associated materials shall be produced by manufacturer with a minimum of 10 years experience in the field of engineering for the product. And this PVC water stop shall be suitable for storage, handling, installation and service within a range of 15 degrees to 35 degrees Celsius. PVC water stops shall be suitable for storage, handling, installations and services with a range of 15 to 65 degrees Celsius. Water stop shall be high performance system. Water stop shall be a high performance system forming a continuous network as shown on drawings. Site joining is to be limited. So we can say water stop shall be a high performance system forming a continuous network as shown on drawings. Side joining is to be limited to butt joints. Side joining is to be limited to butt joints and shall be performed strictly in accordance with sections. Externally placed water stop shall have ribs on either side of center of water stop. Externally placed water stop shall have ribs on either side of center of water stops. Water bar used at location of expansion joint shall have a bulb in center to accommodate motions. There's a point here. Point to be noted that every externally placed water stops shall have numbers of either side, ribs on either side of center of water stop. Water bar used at location of expansion joints shall have to have bulb and center of accumulation of moment. Now, bubble butyl rubber, I think it's possible, yes. Water stop, yes, there's some paper here. Think of this, says, I'd say that saying, water stop shall have a minimum thickness of 3 mm minimum. Minimum test pressure data for PVC water stops shall be as follows. Tensile strength greater than 2 MPa. Water stop shall have a minimum thickness of 3 mm, minimum test performance data of PVC water stop shall be as follows. Tensile strength greater than 12 MPa, more than concrete, you can say. Tensile strength more than 12 MPa. Elongation at break 300%. 300% elongation at break. Hardness shore A 80 to 90. Hardness is shore A 80 to 90. Material shall be tested in accordance with BS2571 or BS2782 or CRD C57 or ASTM D2240. Butyl. Now here's question of hardness. Just a minute. Let us go to see this also. Frankly speaking, shore A hardness, and we have to see shore A hardness such that shore A hardness is a measurement that comes from a shore durometer tool. Shore durometer tool. This tool is used to measure hardness of rubber polymers and elastomers to indicate their resistance to indentation. Higher number on scale means greater hardness, while lower numbers indicate softer materials. I think here is, if you can see, I like to show you this. Let me see if you can see it. It is something about hardness. I think I can't open it. Really? Well, I have some here. It's not durometer shore hardness scale. I wanted to show you, and that is durometer shore hardness state scale. It's here, I think. I'd like to show you this. I'm printing it for your reference. This is what it is. So this is what it says. Durometer shore hardness scale. There are different shore hardness scales for measuring hardness of different materials. These scales were invented so that people can discuss these materials and have a common point of reference. You can see from chart below there is overlap on different scales. For example, a material with a shore hardness of 95A is also shore 45D. Shore 00 hardness scale measures rubbers and gels that are very soft. Shore 00 hardness scale measures rubbers and gels that are very soft. Shore A hardness scale measures hardness of flexible mold rubbers that range in hardness from very soft and flexible to medium and somewhat flexible to hard, with almost no flexibility at semi-rigid plastic. Can also be measured on high end of Shore A scale. Shore D hardness scale measures hardness of hard rubbers, semi-rigid plastics and hard plastics. How do we physically measure a material's hardness? Different shore hardness scales measure resistance of materials to indentation. A shore hardness gauge looks like a round tire pressure gauge has a needle on spring protruding from one end. Needle is placed against rubber or plastic and pressure is applied. Once the gauge is pressed firmly against the material, a needle has penetrated as far as it can go. Measurement needle shall indicate corresponding hardness measurement. What shore hardness means to you as a mold maker? Shore hardness becomes an important factor in considering which mold rubber you should choose for your or for making a mold of your original. Consideration is how easily you be able to extract your original model. For example, you would be choose rubber hardness interrupters. Wait a minute. Let's go there now. What other circumstances would you use a shore 70A rubber? A common application we encounter from world of concrete. Casting would be making molds of flat original models. Paving stones, for example, this model configuration does not require much flex form from rubber mold to extract original or subsequent castings. Using the 70A urethane rubber also gives you tremendous abrasion resistance and therefore longest mold life for this application. So here is a scale, you can say extra soft, soft, medium soft, medium hard, hard, extra hard. There is shore 0, 0, shore A, shore D, shore 0, 0, 0 to 20, 30 like this up to 100 here, and shore A from here 0 to 100 here, and shore D from 0. So you can say where shore is 45, shore 0, 0, there shore A starts, and where shore A is 65 or 60 somewhere, shore D starts. And it says, for example, here shore 0, 10, this is jelly candy gummy, and for shore 30 is gel shoes insole. Likewise, if you say rubber band, which is you can say shore A20 or shore 0, 60. Same a pencil eraser, for example, it is in two-way, shore 76 and shore A40. Same way tire thread, this is in three ranges, also shore 95, shore A70 and shore D15. Likewise these are, so we can say this is about hardness. So I keep it close. This was only for information to you, what I wanted to share with you. And we go to again same, that is our question, our answer, and we wanted to show this from whatever point of view, and we can say that I close this now. Okay, so it's there. It's an interesting one. Water stop shall have a minimum thickness of 3 mm and tensile strength greater than 12 MPa, elongation at break 300 degrees, 300%, and hardness shore 80 to 90. Metal shall be tested in accordance with BS2571, BS2782 or ESTM D2240. Butyl rubber water stop. Butyl rubber water stop. Butyl rubber water stops shall have properties stated in table this one, 12.1, and tested in accordance with BS 903. Properties requirements of butyl rubber water stops. BS 903, Part A1, Part A26, Part A2, Part A2, Part A6. We can say properties. Part A1 is density, Part A26 is hardness, part A2 is tensile strength, part A2 is elongation at break point, and part A6 is water absorption, 48 hours immersion. And requirements are density, that's part A1, 1100 kilogram per meter cube, plus minus 5%. 1100 cubic kilogram per meter cube plus minus 5%, that's density. And part A26, handiness. Handiness actually should be hardness, 60-70 IRHD. Hardness. And then part A2, tensile strength, not less than 17.5 Newton per millimeter square. Then part A2, elongation at break point, not less than 450%. We're talking of butyl rubber, mind it. And part A6, water absorption, 48 hours immersion, not exceeding 5%. Butyl rubber water stops shall be suitable for storage, handling, installation and service within a temperature range of 0 to 40 degrees Celsius. Water swelling gaskets. Water swelling gaskets, where active sealing is required, for critical areas, water shall be hydrophilic polymer. Where active sealing is required for critical areas, water stops shall be hydrophilic polymer. Modified chloroprene rubber strips. Rubber strips shall conform to following properties. Just give me a few minutes, please. I'll be back. You can read mine while. You can read this. It's an interesting one. And I'll be back in 5 minutes. Sorry, gentlemen. I'm back in a couple of minutes, and now here again we're talking of water swelling gasket. Water swelling gasket, which is where active sealing is required, where active sealing is required for critical areas. Water stop shall be hydrophilic polymer, modified chloroprene rubber strips, hydrophilic polymer or modified chloroprene rubber strips. Rubber strips shall conform to following properties as applicable: water pressure resistance 5 bar 50 meters, water presence pressure resistance 50 meters, right, 5 bar, and expansion in contact with water, 2 original SRE, reversible, application temperature minus 30 to plus 70. This is water swelling gasket. Selected rubber strips shall be available for 3 exposures: fresh water, seawater, chemicals, if condition demands or upon engineer's request. Selected rubber strips shall be available for 3 exposures: fresh water, seawater, chemicals, if condition demands or upon engineer's request. Supplier shall furnish references upon request by engineer. Concrete. Now, inspection and testing of hardened concrete. Very important chapter, inspection and testing of hardened concrete. In this we have general, that is scope, references, submittals, quality assurance or requirement, non-compliance of work, general field work requirements. Then we have concrete course, general drilling course, testing for strength, assessment of strength, reinforcement cover measurements, ultrasonic pulse measurements, that is general, selection of test locations, execution of tests, estimated in situ cube strength, radiography of concrete, surface hardness, general method of test, equipment, reporting, chemical content, sampling, laboratory testing. Concrete, you know, everybody knows is very important and expensive material that we use in construction. We use it for permanent inclusion as well as sometimes we use it for temporary inclusions also, but that's very nominal, very small quantity. But if we consider it for permanent work, it's really permanent. It's because of concrete. Other materials which are embedded in are used, like steel reinforcement, and if there is no concrete, steel reinforcement cannot be used. If there is no concrete, we cannot make buildings like we make in current era. We have to depend on hutments or adobe users, adobe houses. Here what concrete gives us life to use buildings, use various other structures. In fact, concrete is such a material which we can call, of course, it's artificial stone, but it can be molded or it can be given desired form, whatever form based on other embedments like steel, and if there is something else, we can say FRP bars or whatever else can be. If you don't have this material, we cannot imagine RCC, we cannot imagine pre-stressed concrete. Therefore, we can say, when I say engineering is life, means you may say concrete itself is a part of engineering, very much part of engineering, and I don't find any location, any place in whole world where concrete is not permanently included on jobs, on projects. Even if we use structural steel, foundations we use that is from concrete, RCC, and even if we do structural steel for purpose of fireproofing, we may use concrete as encasement. And there are various other uses elsewhere in pipelines, in duct banks, in drains, or you can say wherever. If you want pre-stressed housing, we use concrete. So we can say concrete is a kind of general material in construction. It's not a specific one, but its volume is too high, its cost is too high, and it is, of course, forever. As I usually say, concrete can be used for 50 years, 100 years, depending on its strength, its durability. And same way, if concrete can be used for so many decades, other materials used with concrete such as steel can also be used for that longevity, because steel alone cannot be used for either compression or tension. But in concrete, it can be used for both stresses. Whereas hardened concrete can be used only for compression, its tensile strength is very low. But when both materials are used in combination, it becomes a marvelous material, you can say. concrete cannot be considered rarely. Everybody has to deal with this. Every person who is in construction, every worker, every engineer who works in construction, or every person who uses these concrete in housing, in buildings, directly or indirectly, we can say, they all have to share goods or bads or the merits of concrete. And therefore, because it is very significant material, it has immense applicability. It must be valued accordingly. It must be valued accordingly. If we take care of concrete construction qualitatively, it should be done, and it's done all over the world. But in some areas of our country, in some, let's say we as a whole, and also in many other countries, sometimes, we don't care about quality. And that's my question here. Inspection and testing of hardened concrete. It's not only inspection and testing, but also design of concrete. When we design structures, we keep in mind all these properties that concretes give us, concrete provide us for use. And if we don't have good construction, qualitative construction, we cannot use those properties. And that's why I say, think about quality always. And that's why I gave you this talk of little concern or immense concern, you may say, quality in concrete. And where does it stand? That point we have to see as professionals. It's our duty to look into that, or else we stop calling ourselves professionals. And that's no way, and that's beauty of this. We'll take up this issue of concrete in next talk. Because as far as I'm concerned, as an individual and as an engineer, I consider concrete as very important, very significant, very reliable material in our lives. I will not give that much importance to finishing items or to supplementary items like bricks, like blocks. For example, blocks are also constructed of concrete, and brick is constructed from clay. Yet, we rely on concrete itself to maximum extent, and we have to think of it. Means we use complete natural materials for blocks, for concrete work, for brick work. But concrete is, because it's immense in use, brick is not that immense, block is also not immense. Concrete is, once it is done, it cannot be withdrawn, it cannot be replaced. Yes, it can be dismantled, it can be demolished, that is different, but it cannot be replaced immediately. It is something that is much more significant than all the materials. We cannot just take it for granted, because this, once you do it, doing may not take more than 1 day, 2 days for one element, or even for a whole structure, building, let us say 1 year, 2 years, 1 year, 2 years. But if you work on for 1 year and 2 years for structure, it shall work for you for 50 years, 60 years, 70 years, 80 years, 100 years, more than that. we can say a work of 1 unit can give you 100 unit. A work of 1 unit gives you result of 100 units, 80 units. Then you can say scale of that. How useful is that? And that's my point of view. It's very important one. How important is that? I just try to explain my view. I'm not saying that this should be your view. No way, but if you calculate, it should be everybody's view. There is no option in this. There is no option in this. We have to consider likewise, right? We cannot take it for granted. There is no way out to take it for granted. That's the reason I try to involve myself personally in this talk, because after all it's matter of importance, very high importance. I've seen how concrete work is done. I worked in Qatar, Abu Dhabi, Iraq, and these first number one, that is I can consider Iraq. And I worked in there in 1982, 81, and also in Qatar, and I worked there in 1985 to 89, and also 2000, 1986, 1996, 95, and 2000, 2004 to 2005, and 2003 to 2004, and then I worked there in 2000 to 2003, and of course done lot work on that, and I can say I learned from there much more than some institution could teach me from all over world. I owe my experience something that it has been an institution of continuous learning, field institution, or you can say site institutions. I value more to site institutions, field institutions, than to whatever university or other institutions provide. My concern is little different. I take up this issue later on. I close it now. Thank you very much, and I hope you will enjoy.